So those are systems. How do you put the systems together and connect them to your enterprise workflows? And for continuous delivery, there are actually 6 pieces, and I've got a slide for each one of these. We want to have our architecture and our teams uncoupled from each other and clearly defined. And if you're a developer person coming from that perspective, you think of this in terms of microservices. It might help you realize that you want to have all your logic inside a black box, and then you want to have the communication between these microservices or between these black boxes be very simple and easy. And it's the same way for all the operating units inside the organization. If we're looking at that chain of customers earlier and seeing process owners and step fulfillers and people further down the line, we want to make sure each one of those boxes masks its complexity and has easy inputs and outputs, because that reduces the number of dependencies. What that means is then if we're going to pump code out to a new part, to a specific part of our whole enterprise architecture, we can just push it out because it's not dependent on 20 other things, and we don't have to get bogged down, not just from a system standpoint, we don't want to get bogged down from a political standpoint inside the organization of needing deep, fine-grained conversation between people who don't necessarily communicate with each other as well. So then there's this issue definition process, the actual work items. And one thing that is required is to work from a master branch of your code repository. That means you're keeping your master branch fresh on an ongoing basis, and the branches you pull off from it, they either die within a day or they're refreshed all the time. We need to organize all this somehow, so we use a release pipeline, and we need to have automated build, deployment, and testing processes. To get all this to work, these pieces here need to have a common shared structure. If you think about it, they need to talk to each other. And we're having people using machines. People can talk to each other. The machines can't unless we define a common structure. That's the language and keys that set of machines use to talk to each other. And I'll show you one way of doing that works. And then we need workflows that are going to pull all this together and integrate it into the organization's day-to-day work. So the first one is these uncoupled teams. And again, we've got our chains of processes that are automated by systems. And if we're uncoupling the process teams, uncoupling the systems, give each system its own clear architecture, give each system its own variation of continuous delivery, and make it easier just to target one specific set of changes and then push it out, because everything else it has to talk to is a black box that's reliable. So we're able to start to see where the legacy code is in the organization if we're starting to use this code. This approach to define what these things need to be. We're going to see all these things that smell in the code, all these places in our systems where there's a lack of alignment with this, and we look at what hurts the most and we prioritize what hurts the most, and we know to work on those things. And again, if we're starting with a minimum viable product, it doesn't have to be this big thing. It can start with something that's very simple and that works very easily in one part of our organization, and let that pull other people into the process of making this happen. So the next building block is our way of managing our issues. Everything needs to be built with automated tests, but it's based on feedback. So the stakeholders are giving us feedback all the time. We use our knowledge management tool. Like Confluence has this feature called requirements pages that enable us to create a separate page for each requirement, which we then break down into issues. And each one of those requirements is translated at the high level into an epic feature. Then that epic or feature is broken down into, in a version even of the epic and feature, is broken down into several issues. And we're able to schedule the issues out this way. So here's something that to me is important for us to take a step back and think about. And this is why it's so important to have business people in the same room as the development people, because what we're talking about is getting everybody to step out of their box a little bit and start to think about how things can work together better. The stakeholder feedback evolving all the time is really important. You have workshops based on your Confluence requirements pages. But the developers also need to be able to see the code from a broader standpoint. And there are different approaches to this, but we're addressing the same problem, which is we go into something with a design flaw. We don't know we have a design flaw. We get a year into something and we find this flaw. It's extremely expensive to fix that problem at that point. But if we can go earlier in the process and figure out where that system flaw is, we can solve it early. And it's so much cheaper to solve something for a fraction of the cost earlier than it is to wait a year and have to rebuild all the stuff we did over the course of that year. One approach is pair programming. It seems counterintuitive. Why am I paying 2 developers to do one developer's work? Well, the reality is they're sitting down next to each other. They're thinking of it in a new way that they didn't before. Another approach is something called mob programming, where we have an environment like this. The whole development team and some people who are business people even might be sitting in a room like this, and we're all looking at the code up on a screen and we're programming it together as a group, as a mob. And that can get people to think about it and bounce ideas back and forth with each other about it that create new approaches to systems that wouldn't come without that collaboration. So the next building block is this idea of keeping our code in our master branch fresh. So we start from our master branch, and while work is being assigned and planned, we're moving out from that master branch here in the center. But we want to move back towards master during issue resolution. So here what we're seeing are developers who have pushed code into an automation system. Here it dies at this level, it fails, and so you go back, make some changes. This person pushed it passed here at the issue level, and so it merged into the feature version level, but didn't get to master yet. Now you continue this process. This developer makes some changes, pushes it up, makes some more changes, it merges all the way to master. Well, this developer is going to continue working here. What we have is these short-lived branches, so that when this first developer's code gets pushed to master, it actually merges back to this developer, the other developer's laptop, while they're still working on the other issue, so that the integration happens in real time. And then when the second developer is able to make something that pushes all the way to master, they've reduced the need to integrate all of these changes later by fixing the problem up front. Now, one thing people think about when they look at this is when something goes to production, particularly in a company that hasn't even begun this process, there's a whole set of requirements, a hairy process with a lot of red tape in order to approve any change that goes in production. We don't want to remove the logic and wisdom and importance of that from all of this. What we're doing is removing this change approval process upstream so that it happens earlier. It happens in the planning phase rather than at the point where the code's actually been developed. So just bringing it to an example, Facebook, at some point when they got to the point of 1,000 diffs a day, they had to move entirely to automating all of this. But when it was a smaller number, several hundred diffs a day, and they're pushing to production every few hours, what they would actually do was cherry pick. We're only going to put some of these issues up and not others. And if you look at the branching in this way, what you realize is that there is a branch for every issue that was in our, that was defined in JIRA. And that means that that branch in the code repository can be sent straight up to production. And that's something that is valuable. Let's just keep moving to the next one. Your release pipeline is essentially using the same, you remember at the first slide of these 6 building blocks, I said these things have to have the same structure to go all the way through. So here we're off at the knowledge management tool. Somehow we've gotten into the issue tracker. And when we've created that requirements page in the knowledge management tool and the Epicon feature in the issue tracker, it can actually be linked. So in JIRA and Confluence come with this built in to be able to automatically create a branch of your repository that's linked to that JIRA project. And that happens now we're in TFS or Bitbucket. And then when we create an issue in Jira, it automatically creates the issue in the code repository. And then the code goes out to the developer laptop. And the code's developed, unit tests are run, and you're seeing the developer pushes the code into this system. And that's making a commit to the issue branch of the code repository, which of course is related here to Jira. And if that merges, you move up to, that succeeds, it moves up to the feature version branch, which is perhaps here in this model a stage 2 of a pipeline that I'm showing you an example pipeline. And then we've got a stage 3, which is the master level branch in the test environment deployment. And we've moved, in the model I'm showing you, we've moved actually past our code repository into containerization here for your staging, because everything's from master going into a staging environment and then into production. So this release pipeline is basically taking the work that's done from the developer check-in out to production and breaking it out into several stages. So that leads us to this building block of we need these automated processes for building, for deploying, for testing. And again, we're starting with the developer laptop that does unit tests, and it's going into stage 1 in the pipeline. We can actually auto-deploy the environment because our infrastructure is code. And that means every developer who's working on an issue can create their own environment very quickly, spin it up and run these tests. Triggers automated build processes, automated deployment, automated tests, merges the code up one level higher, the next pipeline stage happens. You spend some time here looking at how your environments are going to be set up. You can be more flexible with that if the environments are defined as code. It's possible to spin up environments at different points in a process, like I'm spinning up an environment in each of these pipeline stages as I'm showing you. So if you've got several developers, each coming into pipeline stage 1 separately because they're working on separate issues, you might have your stage 2 of the pipeline require all of them to, or several of them to merge their code together before it moves up to the next level. And that's something you happen in workshops and thinking together as a group about how you set things up. But simplifying it, you might consider auto-deploying your environment, trigger these build and test processes, merging up to master if everything works. And then here, still in the test environment, this can be spun up every day. It can be spun up at the point of process. You have these same things happening. And here what I'm suggesting is at some point in our process, we're going to move away from our code and we're going to move into images that are going to be instantiated into containers because these have been vetted. And so then we store our containers in one of these registries, and our staging can be similar. So we move out, run these whatever types of tests we're running in a staging environment, store the containers, and enables us to move to production. And you're seeing that in order for continuous delivery to happen, we've got all these automated processes. And it's not that hard. It's just it needs to happen and be structured, and people need to be engaged in thinking about it. So then we need workflows in order for this to happen. And where the rubber meets the road is the issue resolution workflow. That's where people are doing work every day, and that triggers this automated release pipeline, right? We went into some great depth about all of this stuff, but now we've just abstracted out, and we're starting to look at this not so much with our engineer cap on, and more so with our business manager cap on, and see that this is the microcosm that we just spoke about. We need to connect this with our enterprise in order to be able to capitalize on opportunities faster and do all that fun stuff and be more like the Lakers and less like the people who don't want to work with each other. So we need a feedback-driven requirements gathering process. And this is getting people who are not technical at all and people who are, getting them in together looking at a problem and figuring out what the requirements are and how they need to evolve based on feedback. This is going to trigger different workflows. We break our big projects down into these epics or features that are big pieces of work that get done. We then need to break down each of those epics into individual issues and prepare those. We got a workflow for that. Then we need to somehow assign this workflow. Now, if we've never done any agile before, it might be easier to move to a Kanban model than to a Scrum model. There are different ways of assigning work, but one way or the other we've assigned work, and that triggers this issue resolution workflow. And here we've been all people, and now we're getting into systems. So again, we're starting a project and we want to integrate with this. We want to capitalize on this stuff. We need a way of starting our new project. And at the workflow level, that means our project is going to have a way that we define our epics, and a way that we define and prepare our issues, a way that we assign our work, a way that we resolve our work, and an automated release pipeline. And like anything else, we can start with some best practices. We don't have to build all this stuff up from scratch. So our project creation workflow can have a minimum viable product for each one of these things. We've got these workflows for our continuous planning, continuous delivery, and I showed you at the beginning of this 6 building blocks that we need a common shared structure for our issue definition process, our trunk-based code repository, our release pipeline, our automated build and deployment and testing processes. They all connect with these workflows, and the result is clearly defined an uncoupled architecture and team if we're putting it together. So I'm taking the same things I've showed you before, I'm sitting with it from a different angle. So the different types of people can be drawn into this and it can become more intuitive. And again, all this, we've actually documented an approach to doing this that we've done and validated. All this is stuff that's easy to start up with without having to reinvent the wheel. So let's look at all of this from the standpoint of how these systems relate in the developer's actual work. We start with this process of translating requirements into issues, and that needs to connect to our continuous delivery release pipeline. So we've got our knowledge management tool over there, which has defined a requirement, and we have translated that requirement into a feature in the issue tracker tool and decomposed that feature into versions that are composed of issues, and that issue has been assigned to this developer who's a blue triangle. Then our code repository has a master branch in it that gets its first commit. A branch is made for the feature version in the code repository, and a branch is made for the issue. The developer checks out that branch, and we start this process of integrating with the continuous delivery pipeline. We trigger pipeline stage 1, where the developer makes a commit back to a second commit to this issue branch, and maybe an environment's deployed. They make some changes because it fails the first time, and then they make another commit, which is the third commit to this branch, and it pushes forward this time into pipeline stage 2, maybe an environment's deployed for that. They make some changes, and this time it pushes all the way through to master, and this time it passes. So then, we may have, at one point in your journey, because this is a journey to these things that involves change management by a lot of different people in the organization, you may have a manually approved deployment to staging, and then you move to production. And this is just all these concepts we had before, and now we're showing you all of this in one slide where it's one issue being resolved, connecting all of these systems across all of these stages in a pipeline.